Let me welcome you to the 31st lecture of surface mining technology. From this lecture we will start excavation with surface miner. So, there will be 5 lectures on this. So, how the surface miner is working and what is the present status, we will discuss all this in these 5 lectures. So, as we do in every class, let us once look into the learning background required for surface mining technology course, and these are the learning objectives for surface mining technology course, and these are the expected learning outcomes from a participant of surface mining technology course, and these are some of the textbooks and references which participants may follow. And so far we have covered the in surface mining technology course the phases of mining a deposit and what are the unit operations associated with every phase, and then we have covered the commencement of surface mining through opening a box cut. Then we have completed the drilling technology, blasting technology for fragmenting the rock into the handable sizes. Then we have covered the shovel excavation by shovel. We have covered the truck transportation system and matching of them shovel dumper combinations. We have also covered the excavation of the soft rock material using a ripper. So, that is also covered in the previous lectures. So, in this lecture we will start another technology after ripper, the second technology in which we can go for the blast free mining system. So, that is the excavation of rock material or in situ rock mass using a surface miners. Often it is referred as the continuous surface miner also. So, the objective of this lecture series, this 5 lectures will be carried out on this to understand the application of surface miner, to understand the cutting principle of surface miner, design and method of operation for surface miner, and to understand the cost and performance calculation for surface miner. So, these are the broad objectives we are trying to cover in this 5 lecture series of on continuous surface miner. But before going into the details, let us just look what is surface miner in this video. This is the video of a query, and this machine is called surface miner, which is you can see a 4 crawler mounted machine and having a discharge boom which discharge the cut material. After cutting this, the material is being discharged. So, there are n number of variations possible with this system, and you can see this is a very good sized material is being excavated and that is being dumped in a row. So, this is called windrowing. We have also covered that shovel is often also allowed to go for windrowing. So, you can see this is very sized material and that is why it is conveyable also. So, the material is cut by the machine, then the material is lifted by the machine and material is discharged by the machine. So, this is the in a nutshell, this is the operation of a surface miner. So, a surface miner basically works on the principle of cutting. So, it cuts the in situ material, and the interesting part is that it cuts the floor. So, the material is basically cutting the floor on which the material is standing. So, it is basically cutting in between the front crawlers and the rear crawlers. So, material is cut. So, the rear crawler is standing on a lower platform, upper crawler is standing on a upper platform. There are other variations also available with the machine, where the cutting drum is placed in the front of the machine. So, material cut in front, it is also cutting the floor, but in front of the machine or in the rear of the machine. Generally the cutting drum is placed. So, these are the variations, and necessarily all the surface miners are having the cutting system based on the peak mounted system, where the cutting peaks are placed on a cutting drum, and as the drum is rotating, the cutting peaks are cutting the material. So, you can see the size of the surface miner is a big system, and this is the operator cabin. This is cutting drum is placed at this position, the front crawlers, these are the rear crawlers, and the material is being transported in the back side of the machine. This is the primary conveyor which is taking the material, and this is the discharge conveyor which is gradually discharging the material. In this case, the material is being discharged in windrowing system, or you can say material is discharged as a side casting system. So, the machine can be observed that the machine is also having a good speed of cut. So, the discharge quantity is also significant. This video is available in this YouTube link. And this type of machine can be applied for surface mining, it can be applied for the cutting for the roads, it can be applied for the trench construction, it can be applied for the excavation of the surface profile. So, there are n number of applications of surface miner. If you look into a retrospect into the history of this surface miner excavation system. So, surface miner was basically evolved 1970s onward, and this was basically developed from the concept of road milling machine. So, that is why it is a actual origination was for the civil work, but later on mining sector it has found that it has significant applicability. So, that is why it is adopted, and the main reason for the popularity of this system is that this is very economical, and that is why it is adopted in most of the mining cases. So, now let us look into the details of this machine. So, surface miner was developed. So, in a nutshell, you can say surface miner is a rock excavation machine essentially fitted with a cutting drum which rotates to cut the rock mass. So, this is the generalized definition of the surface miner, and if you look into the history, surface miner was developed in 1970s and originally modified from a road milling machine. The first introduction of the surface miners was carried out in a bauxite deposit of South Africa, and later on it is became popular. First it was introduced in Indian limestone mines in Gujarat Ambuja Cement Limited in 1995. A second hand machine of Wittgen GmbH was deployed there on a contract basis. So, that was basically an experimentation or field trial you can say, and later on it has been found that machine was found very acceptable, and that is why it was widely accepted in the surface mining technology, especially the limestone and coal deposits which are basically bedded deposits have opted for this machine. And so, it was developed initially taken in the limestone mines, later on around 10-15 surface miners were deployed in the limestone mines, mostly for the cement sectors like India Cement Limited, Madras Cement Limited, Gujarat Ambuja Cement Limited. They have opted for mining with these limestones, where the especially the strength of the limestones are lying between 50 to 80 megapascal. Later on in 1999 it was deployed in coal mines. First it was deployed in Lakhanpur open cast project of Mahanadi coal field, where again it was deployed on experimental basis, because in that particular mine the blasting was prohibited because of the close proximity of the inhabitances. So, that is why on experimental basis surface miners was deployed there, and the initially it was deployed in a very high price 60 rupees per meter cube, but later on it has been found that there was a significant reduction in the price also, and in 20 rupees 30 rupees per meter cube also was found profitable for the mining with surface miner. So, experimental run on bauxite was carried out in 2010 in NALCO, but that experimental run was failed. Currently around 500 surface miners are working in over the world, among that 133. So, almost more than 1/4, almost close to 1/3 surface miners are working in India. And if you are looking into the worldwide, around 188 surface miners are working in limestone mines, 129 surface miners are working in coal mines, and 51 surface miners are working in iron ore mines. So, it has been found that applicability of surface miners are there with the strong deposits like iron ore also, and most of these are belongs to Australian iron ore mines. That means, the surface miners are applicable for soft rock to hard rock also, depending on the formation characteristics. It has been found that surface miner is was applied for granite rock also in a tunneling project of Japan, and there are n number of other applications. It has been utilized for construction of the ground, it has been utilized for the construction of the dam. So, there are different applicability of the surface miner. Now, let us look into the detail of the machine. This is detailed about a particular machine, where the cutting drum is placed between the front crawler and the rear crawler, or maybe the vice versa also, and cutting drum is operating in a up cutting direction. So, the drum is rotating. So, the drum is rotating in this direction. So, it is cutting in upward direction and material is moving like this. There is a scraper plate, this is a scraper plate which is placed behind the cutting drum. So, whatever cut material is available, so the cut material is allowed to remain or encased with this housing system. This is the drum is rotating, this is the front housing system. Up to this it is a closed surface, back side is closed with a scraper plate, and this is the primary conveyor which is placed at this position. So, this is allowing the fragmented material which is cut by this cutting drum, cutting peaks. Then the fragmented rock material is allowed to remain in this encased area, which is allowing further crushing of the material into a smaller size. Then as the material is filled with this void position, then it is there is a small opening which is opening towards this primary conveyor. So, through this small opening the material is coming into the primary conveyor in a smaller size, then that is conveyed to the secondary conveyor, and then from secondary conveyor it is discharged whatever is the way, either to a truck or to a conveyor system or to the windrowing system or side casting system. This is the front crawler or rear crawler, this is the front crawler or rear crawler, there is a two sets of both, and this is the machine. If you are having the water sprinkling system, you have to provide the water sprinkling systems to this. This is the secondary discharge conveyor is slewable, secondary discharge conveyor can be angled and lowered, upward, all these facilities are provided. This may be a diesel operated, this may be electrically operated also, and these are the more or less facility provided here. And this scraper plate is very important. This is allowing post cut a smooth floor surface. So, this floor surface is kept smooth, and this smooth floor surface is allowing the better tire life for the pliable machines also over this floor. So, this is a benefit in this system, and that is why it is wholeheartedly accepted. So, components are cutting drum, cutting picks, scraper plate, primary conveyor, secondary conveyor, cooling arrangement, different drives, machine acting on weight acting on the drum, and depth of cut. These are hydraulically controlled. These are the features for this particular model of the surface miner. There are other models also. There are some models are having some advantages, some are having some disadvantages. So, all these are mechanical control systems are there. So, surface miner can be broadly classified in two ways. One is that the cutting drum is positioned in front of the machine. So, this is the cutting drum positioned in front of the machine, and this is allowing the rotation of the cutting drum like this. This is the allowing rotation, and second type is that positioned between the front and rear crawler. So, this is down cutting, this is up cutting, and both can be reversed also depending on the type of application this can be made. So, these are two broad classification, one is in the front of the machine, one is below the machine. The basic difference is that in this case the machine weight is acting on the drum and give an additional normal force. Gives an additional normal force. Here the drum has to make the heavy, so that the sufficient normal force can be given. Otherwise, the moment drum is allowed to cut this one in a normal force, the drum will try to jump from the floor. So, you need to provide a sufficient normal force, so that it can cut the material. So, in this case the machine weight is acting on this. So, the significant normal force is given, but in this case you have to additionally weighted this drum to have this normal force, desired normal force. So, let us watch videos of this one. So, this is the YouTube link for this video, and this is the cutting drum placed in front of the machine or rear of the machine, and the material is being excavated like this. So, as the crawlers are moving and the material is being cut in the down cutting direction by this drum. So, machine is moving in front direction, machine is moving in this direction, and material is being cut like this. So, this is the down cutting direction and the where the cutting drum is placed. In this case it is behind the machine, and this is the depth of cut. You can see up to this the cutting depth is achieved. So, the problem is that in this case that crushing is not possible, because there is no encasing of this cut material. So, cut material is basically thrown back to the cutting direction, and that is why a little bit lump size boulders are produced here. So, this is the depth control system, which is allowing the controlling the depth of cut, and this is how the cutting is carried out, and these peaks are basically fixed with the cutting drum like this. And this is the other one where the cutting drum is placed between the front and rear crawler, and this is the way up cutting, in up cutting direction the drum is rotating. So, here the empty run of the drum is showing in this video. When this will lead to, after lowering this part, this drum part, it will start cutting. So, now gradually the drum is being lowered and the drum is allowed to cut the material. So, this is the rear crawler and this is the front crawler and this is the cutting drum which is moving. So, in this case the heave of material is left behind the machine, and that is why this is a there is no conveyor system used here for loading the cut material onto the truck. So, separate loader has to be utilized in this case. So, this is cutting in up cutting direction. So, surface miner applicability can be dictated by the rock parameter, machine configuration and type of application. Among the rock and rock parameters, moisture content, density, brittleness, compressive strength, point load, Young's modulus, tensile strength, abrasivity, sonic velocity, volumetric joint counts, stickiness of the material. So, these are the main properties or influential properties which are dictating the applicability of the machine, and this is rock mass, uncontrollable rock mass, and these are the machine configurations, cutting tool configurations. This is the rake angle, attack angle, clearance angle. We have already covered these details in the chapter of Reaper class, excavation by Reaper in those class. So, apart from this, we are having peak lacing, type of peaks which are used, number of peaks, material of the peaks, drum weight, engine power is very important, that is we have seen in Reaper also, and whatever coolant we are using for the cutting tips or not, that is also another machine configuration which are influencing. So, this is uncontrollable, this is one time controllable. After choosing this, there is a very little chance for the users to change this. So, this is depending on the machine model, but user can change the type of application. You can opt for different mode of operation, modes are windrowing, conveyor loading, etc. Length and width of the operating area, if you are providing more length, then the performance will be increased. Operator skill, a skilled operator can negotiate the depth of cut very well, and that is why proper utilization of the machine can be carried out, and specific requirement like dry weight, fragmentation required depending on the peak lacing has to be carried out. So, these are the important parameters the user has to control at his end to achieve the desired performance from a surface miner. So, this is very important and should be controlled. So, there is a rock for which first job is to decide for a suitable machine. So, after that, so there is a more or less good match between these two. Type of application is basically there to enhance the performance of the machine. So, that is the importance for this, and this is very important while the applicability is basically decided in the surface miner. Now, this is the mechanics behind the surface miner. If this is the cutting tip which is basically acting at this place, then if this is the cutting tip, this is the clearance angle, this we have seen similar to our repair also, this is called rake angle and this is the wedge angle that is known, and this is the cutting angle with the axis of the peak. So, the moment when the peak is striking on this is basically has two component, one is the normal force, another is the drag force. So, the crawler is, this is the after hitting, this is the normal force, this is the drag force. Apart from that, this peak is also dragged by the crawler system. So, that drag force is also acting on this. So, this normal hitting force plus drag force given by the crawler is basically the drag force, and normal force is hitting, and along with that the machine weight is also working at this position. So, that is why these are the force calculation of the force, how the machine is applying force for excavating this rock material from this position, from this area, how it is excavating this portion of rock, how it is taking a bite. So, this is basically given by this. After a good research, it has been found these two are very important. So, a clearance angle close to 5 degree is basically advised for surface miner, and it has been found this is 5 degree clearance angle gives the optimum result in case of surface miner, and a rake angle of 25 degree is considered as the optimum rake angle for a surface miner excavation as per the British experimental research. Okay. So, these are the rule of thumb, but this all depends on the type of peak also. There are different types of peaks are available, for they are having their own different types of applications, like for soft rock the peaks are different, for hard rocks the peaks are little bit wider with a more, greater wedge angle. So, these are the different types of application. For abrasive material also you need to have a larger wedge angle, and this and more drag force for the abrasive material. These are important part that has to be taken care while the selection of machine is and selection of the cutting system is considered in case of surface miner. And this is another picture which is giving the details of the surface miner working principle. So, this is more or less about the introduction of the surface miner, which is giving the little bit idea about its application. We are not going into the details of the application, but I would like to refer one book in this case. There is a book available which is basically a book for the lathe operation, that is a metal cutting by Professor Amitava Bhattacharya. That book is suitable for the surface mining cutting operations also. Principles are more or less same, but in metal cutting generally we are having rake angles in the negative side also. So, that is depending on the different applications. So, those physics behind those cutting system can be more detailed, or that can be studied from that book. So, this is more or less introduction about the surface miner applications. We will go continue to the next class about the classification and working method of the surface miner. Thank you.